All right, another thing that is kind of interesting, at least in my mind, which I don't care if you agree, but wormholes. Anyone know what a wormhole is? We can technically use this for space travel. What's a wormhole? Whoever's raising their hand very high.
It's like a shortcut to point A, from point A to point B.
Where's point? Yes.
One universe to another universe.
Yes. Basically, yeah. No, you're right. So if anyone knows like what quantum bubble theory is, theoretically there's like a variety of universes. And depending on how much you believe in this quantum theory, then the universe could be understood as like soap bubbles, which each universe is its own bubble, whatever. Anyway, the way to get from one universe to another, or from one portion of space-time to another portion of space-time, is a wormhole. And theoretically, it would be great if we could harness however wormholes happen, which they're only theoretical at this point, and use them for space travel. Because the cost of that is zero, theoretically, because the wormholes are naturally occurring. But even if we could make a fake one, we would have to stabilize it through something like dark energy. But to choose that,
Albert Einstein's general relativity laws allow for the existence of wormholes. In 1930, Einstein and his colleague Nathan Rosen.
Really?
You are a cheat.
Calculated the mathematics of one of these intergalactic pipelines. It became known as the Einstein-Rosen Bridge.
A wormhole is a solution of Einstein's equations for general relativity, telling us how gravity works. They're hypothetical, and what they do is they connect different parts of space and time.
The Einstein-Rosen mathematical wormhole arose from studying black holes. A black hole is a region in space of extremely strong gravity. The gravity is so strong that there is no way for objects that get too near to break away from its gravitational pull. Nothing can escape a close encounter with a black hole, not even light.
This inverted fountain serves as a visual analogy to what's going on around a black hole. At the bottom is the area inside the event horizon. And the water falling into it is analogous to gas that might fall into a black hole. Imagine yourself being a fish swimming around this region. Once you get down inside the central portion, you're past the point of no return.
But Einstein never intended his wormhole as a tool for space travel. His wormhole is theoretically created at some moment of time. It opens up briefly, then pinches off. Anything that tries to pass through it will get crushed when it squeezes apart.
The typical wormhole that you write down in your equations and study is unstable. It'll vanish in an incredibly short time. So what you need is some means of holding it open.
Scientists began to investigate whether there might be a type of wormhole different from Einstein's that is traversable. Traversable wormholes needed something to prevent them from pinching off.
You want to stabilize the wormhole. You don't want the wormhole to collapse. Keep the wormhole open. That requires something new called negative matter or exotic matter. We've never seen negative matter before. It would have anti-gravitational properties. So one day, if we ever find negative matter, perhaps that's the key to stabilize the wormhole.
The idea of a traversable wormhole captivated science fiction enthusiasts. It also reinvigorated the serious study of wormholes within the science community.
This transversable wormhole created quite a sensation, because perhaps it is physically possible to one day build a subway system to another galaxy.
Scientific ideas considered far-fetched today could one day become as acceptable as the fact that the Earth is round. The laws of physics may allow for the existence of wormholes, tunnels providing shortcuts through space as well as time. So could these cosmic subway systems theoretically be engineered into time machines? Einstein's general relativity laws reveal that time travel into the future is possible. They show that time is perceived differently depending on where one is in the universe and how one moves. Objects moving at close to the speed of light age slower than static objects. And objects near a gravitating body age more slowly than objects farther away.
Clocks run at different rates in different gravitational fields. The stronger the gravitational field, the more slowly time passes relative to someone out in space where there's no gravitational field. On Earth here, on the surface, our clocks run slightly more slowly than clocks high up in the sky. So an example of this is that the clocks in the GPS system of satellites run a little bit more quickly than the clocks here on Earth because they're in a weaker gravitational field. And the scientists and engineers developing the GPS system had to take into account the different rate at which clocks run. If they hadn't done that correctly, then your GPS system wouldn't work. If you were taking a trip from Los Angeles to New York, you'd end up somewhere in Massachusetts.
Forward time travel has been tested using highly precise atomic clocks. Scientists have placed one clock on the ground and another in a rocket flying high above the Earth. The two were compared using radio signals between rocket and ground. The clock on the rocket ticked faster.
Here on Earth, my clock is running more slowly compared to someone in a rocket ship somewhere further away from Earth. So their clock is moving more quickly, they're going to the future faster.
Physicists have studied whether wormholes could provide travel not only to the future, but also to the past. If there was a wormhole with one mouth near Earth and the other in the center of our galaxy, the rate of flow of time will be different at the one mouth than at the other when compared to the external universe. But when looking directly through the wormhole, the rate of flow of time appears to be the same. This difference in their relative ticking rates, as viewed externally versus viewed through the wormhole, would convert the wormhole into a time machine.
I thought that was interesting. I don't know. I would kind of like to be able to time travel. Okay, I have potentially one or two more. We're going to do this one for sure. Because we got time.
Nothing but time.
This is, oh, yes, so long. This is the Navy tried to do the electromagnetic launch.
No.
What the heck? That hit.
Listen, brother.
Playground rules. You don't heckle me.
Unfull screen the power.
I don't know.
What is happening?
In time. It gets kind of loud when you're doing super common.
It's a little cold out.
Also chilly.
He's saying secret military things. That's about to be really awesome. Pay attention. That's what he was saying. Let me interpret. Moving. I have to move. That's what's happening. Now I will be.
That guy's just like,
Why are you down there? Not
You
me.
should move.
Yeah.
That is boss to be standing under a naval aircraft and you have to take off.
Alright.
That's electromagnetic force.
That's
Turns
why
out,
it can take off so fast, right?
yeah, it's faster. And cleaner.
Yeah. It is why it's so cool, actually. A giant jet will launch you 50 feet.
It also apparently makes everything look like a giant bug once it gets far away. And for good, it was. Thank you. And then also back to the little dude that's my friend. Copy. And whoa, that's a spreadsheet. Okay. Don't worry about it. Just let it out.
Oh,
We believe that love is a chemical reaction.
This has
Chemistry has a good chance to make the world a more harmonious
not what
place.
you were looking for.
Chemistry works, so the plasters end up loving the water. Families are less afraid of energy bills. And even cars and city centres get along better. That's why we don't just make chemicals, we create chemistry. BASF, the chemical company.
Today I'm going to unveil for you a warp drive that will take us to the stars. All you need is one ingredient, negative energy, and that is the gasoline. That's the fuel necessary to drive a starship. So here's what the design looks like. When I engage my warp drive generator, a whole planet's worth of power courses through the system. Huge gravitational energy distorts space-time, and I reach the farthest realms of the universe in an instant. So this is the key to the design. You compress the space in front of you, you expand the space behind you, and the combination of the push and the pull sends you faster than the speed of light. Manipulating space-time like this would be highly dangerous. Space debris from collisions with the warp bubble might hurtle toward my craft, or I could be catapulted into deadly direct contact with the walls of the bubble. But if I could create enough energy for the warp drive, I'd have enough power to generate force fields like the deflector shields used in Star Trek. My ship would be safe. So then you ask the question, well, what's the catch? To power a warp drive engine, you need negative energy, lots of it, comparable to the size of planet Jupiter. At the present time, we can only harvest minute quantities of negative energy in the laboratory, but it's not science fiction. Maybe in outer space, aliens have already done it, perhaps our descendants will do it. All of a sudden we realize, hey, maybe the Enterprise is not so far-fetched after all.
Yes! You rock!
Did you copy the tweet?